We are turning next to problem number 21 of section 5.2, and to summarize the instructions there, it says that with training, 85% of people who are lying can pass a polygraph test. A polygraph is a lie detector. 9 people are trained and then instructed to lie at some point on the test. We want to know what's the probability that all, more than half, no more than 4, and none of them will pass the test. So we need to set things up here once again as a binomial distribution. So the number of trials is the number of people who are going to be taking the test. So the number of trials is 9. Success, we're going to say, is that the person is lying and also passes the test. So the probability of success is 0.85. That, of course, means the probability of failure is 1 minus that, or 0.15. And R will depend on which part of the question that we're answering here. But just taking note of the fact that this is a binomial distribution. All right, part A. What is the probability that all of them pass the test? Well, that is the probability of getting 9 successes out of 9 trials. And you could use the calculator on this, but it's actually just a little bit easier to use the formula. C99, which is automatically 1, times 0.85 to the 9, and probability of failure is 15%, but that occurs 0 time, and this reduces immediately to 0.85 to the 9th power, and that number is 0.231617, if I round that off. So about 23.16% of the time when this happens, all 9 of them would pass. B, what is the probability that more than half pass? Well, half of 9 is 4.5, so more than half would mean that R is 5 or more. Now, this we don't have a calculator function for, but we do have a calculator function for summing, taking R less than or equal to something. So let's take the complement. R is less than or equal to 1 less, 4, and on our calculator we're going to look that up as binom CDF. There are 9 trials. The probability of success is 0.85, and we're interested in getting 4 or fewer successes. Okay, scroll down to our binom CDF. 9 trials. Probability of success is 0.85. We are interested in 4 or fewer successes, and that gives us 0.0056, but of course we're interested in 1 minus that. We can get that easily on the calculator. 1 minus second ants. It's the minus key right at the bottom. Whoops. Minus second ants. That's the you press the minus key right next to the enter with a second, and I get the result 0.99437. And of course, if you would prefer to get this number from the calculator, it's about 0.005627, or rather 29. You could plug that in here and then do the subtraction on your own. All right, third part. What is the probability that no more than 4 pass? Well, if no more than 4 pass, that is saying that less than or equal to 4 pass. Well, that is what we computed last time. And when we ran that on our calculator last time, we got 0.005628 if you round off at that point, and that's the answer for less than or equal to 4 passes. Finally, what's the probability that all fail? Well, that is the probability that the number of successes is 0. This, once again, you can use the calculator if you want, but it's actually easier to use the formula. We have 9 trials, 0 successes. Probability of success is 0.85, but that occurs 0 times. Probability of failure is 15%, that occurs 9 times, and you can see those two things are 1, so this is just 0.15 to the 9th power, and that turns out to be, well, my calculator tells me this, it's 3.84 approximately times 10 to the minus 8, and what that means is that you take this decimal point and you move it to the left 8 places. So that means I'd have 7 zeros in front of the 3. 1, 2, 3, 4, 5, 6, 7, and then 3, 8, 4. That's the probability of no successes. Not very likely at all. We really wouldn't expect to see this happening in this situation. So with 85% probability of a single person who is lying passing, we really think that all failing is so incredibly unlikely we would never observe it. So that is problem number 21 on section 5.2. Next up is problem number 23 in section 5.2. This question really functions as 2 separate questions. We're told that 75% of marketers are extroverts and 60% of computer programmers are introverts. And then we're asked some questions about a group of 15 marketers and some other questions about a group of 5 programmers. So we really will deal with these two in completely separate ways. They don't interact at all. So let's take a look at the first part here. We're looking at a group of 15 marketers. So n is equal to 15. This, of course, once again is binomial distribution. We're classifying each of the marketers as either an extrovert or not an extrovert. The probability of being an extrovert, if one is looking at a marketer, is 75% or 0.75. And out of this group of 15 of these people, we want to know what's the probability that 10 or more are extroverts. So for part A, we're first asked this question: what is the probability that out of the 15, 10 or more are extroverts? Now, of course, I've set this up as if success is being an extrovert here, and it's just natural to do because that is the probability that I was given. So we'll do this again by complements. Why? Because we have a calculator function. We don't have a calculator function that will get us the probabilities for 10 plus the probability plus 11, etc. through 15. But we do have one that will start at some particular point and then count down. So 1 minus the probability that r is less than or equal to 9, and of course that is the binomial CDF function. Number of trials is 15. Probability of success 0.75, and we're interested in 9 or fewer here. So that's 1 minus. Let's pop that up on our calculator. Distribution, we come down to choice B, binomial CDF. In this case we have 15 trials. Probability of success is 0.75. We want 9 or fewer successes. That number is 0.1483. If you round that off, you're going to get 1.837. And the calculator tells me that's 0.85163. So about 85.2% is the probability that 10 or more of these 15 marketers will be extroverts. There's another question in this part. What's the probability that 5 or more will be extroverted? Well, if you think about this, if we were to write this out with the full probability distribution as we did some of the earlier ones, our possible outcomes are 0 through 15, and with the greater than, you're summing to the right, so we're going down further, and we're summing up therefore more of the outcomes, and therefore we should get something bigger than this. This was already pretty high at about 85.2%, so we're expecting something quite high for r greater than or equal to 5. Of course, once again, you do this by complement. 1 less than 5, 4. And since the last thing we did with our calculator was a binomial CDF, we can do the second entry, do that twice to go back 2. Now we're interested in not 9, but 4. Or fewer, and that's a very small number. 0.0001153. Now, if you don't want to type that in on your calculator to do the subtraction, the easy way to handle that is to use the ants key right down here. It's that just above the minus, you access it by pressing the second first. So I have that number on my screen. I'd like to subtract it from 1. I do 1 minus second ants, press enter, and I get 0.99988. So in a group of 15 marketers where the probability of success, probability of being an extrovert for any particular one is 75%, the probability that I have at least 5, that is at least a third of my 15 will be extroverts, is 99.988%, or very, very high. Okay, finally, what is the probability that all will be extroverts? Probability that R is equal to 15 is what we're after then. 15 out of the 15 are extroverts. You could do this, and I think the easy way to do this is with the formula, because that's going to reduce to the probability of success to the 15th power. Well, that's 0.75 to the 15, which is 0.0, well, it's about 1.34%. But let me show you how to get that with the distribution function. This, notice, is no longer an inequality in here. You don't have a less than or equal to, you have an equal to. So that's the PDF function. So let's do it that way. I'm going to do second distribution, and cursor down to choice A, binomial PDF. I have 15 trials. I want to know what is the probability that of success is 0.75, and I want to know what is the probability that all 15 will be extroverts. Probability is not real high, but we did get that. That is the number we got just from the formula. It's 0.01336. Which of course move that decimal over 2 places, 1.336%. actually fairly small. And you would expect that because there's a 25% on any one of them being not an extrovert, and you get 15 tries, so it's fairly likely that you'll get at least one is not extroverted. Okay, so that takes care of part A. Part B, we really are changing gears here. We're looking at a group of 5 programmers and the probability of being introverted for a programmer is 60%, so everything really is changing. So n equals 5, that's how many are in the group. The probability of success in this case is 60% or 0.6. And success in this case is introvert. And we're going to answer some questions about probabilities of various numbers out of 5. Okay, so in the group of 5 programmers, what's the probability that none are introverts? That is 0 successes. And that's just a single outcome. It's not a sum downwards, not a less than or equal to. So we'll go to distributions, and binomial PDF is what we want. In this case, we have only 5 trials. The probability of success is 0.6, and we are interested in no successes at all. And 0.01024 is the answer for the first part of part B. What's the probability that none are introverts? What's the probability that 3 or more are introverts? Well, if 3 or more are introverts, that's 3, 4, or 5. That is the opposite of 0, 1, or 2. And that is done with the binomial CDF function. So down to choice B. Binomial CDF, we have 5 trials. The probability of success is 0.6. We are interested in the case of 2 or fewer successes. So or fewer means we're going to use the CDF rather than the PDF. So 0.31744. And when that is subtracted from 1, I have 0.68256. And the last part of the question is, what is the probability that all are introverts? Well, that's asking me what is the probability of 5 successes in 5 trials. Once again, you can do that. If you have all success or all failure, there's a simplified version of the formula that will work. So I want all successes. That's just going to be 0.6 to the 5th power. But if you want to do it on your calculator, it's a binomial PDF. It's a P rather than a C because we don't have an inequality here. We have an equality. 5 trials, 0.6 is the probability of success, and I want all successes. So 0.6 to the 5th power is 0.07776. So about a 7.8% probability that all 5 of them will be introverts, which was the question we're asked here at the end of part B.